All right. All right. I don't see any folks on it yet, but it's going to disconnect very soon. Cool. All right. Welcome, everyone. I see already some viewers in there. So for today, while still waiting for everyone to join, in the meantime, please put in the chat where you're watching us from. Just pop in and say hello. We'd love to know where everybody's watching from. And so today, the agenda for today, as we get started here, I'll do a short introduction to Streamlit presentation. So if you're familiar with Streamlit or not, this is a good opportunity for you to learn more about Streamlit. And then we'll hear from Ayush, who is a machine learning engineer from LanceDB. He'll walk us through a demo on how to optimize your RAG applications with hybrid search and re-ranking. And then at the end, you, as the audience, will also have an opportunity to ask him questions based off on the presentation. And then also, feel free to share your applications, your demo, your new Streamlit apps. You'll have an opportunity. Just put in the chat that you want to demo an application. We'll send you a link. You'll be able to come on the stage, just like Ayush will, and you'll be able to share your demo app here with everybody. So feel free to do that. Raise your hand. Let us know if you have a demo app to share. We'll bring you on, and you'll be able to share it. And with that, let's just kick it off. So my name again is Tony Kipkimboy, and I am a developer relations engineer at Streamlit. And Streamlit is an open source Python library that most of you might already be familiar with. And so, just to get started, most companies and developers struggle with extracting value from their data. And maybe you're a data engineer, data scientist, you're already kind of familiar with this already. And one of the major reasons for this difficulty is it involves building the tools to generate insights from the data much faster. So you have the data, but the tooling to generate these insights might be what's slowing down the process. So the typical workflow starts from using a Jupyter notebook, for example, to explore the data and all the way through to building a functional app using front end tech stacks like JavaScript, HTML, and CSS. And of course, this consumes a lot of time and effort. So this is where Streamlit plays a very crucial role. And Streamlit is a faster way to build and share data applications. So Streamlit is an open source Python framework, like I mentioned, that delivers dynamic data apps in a few lines of code. If you know Python, you essentially know Streamlit. So there's no need to learn the front end tech stack like JavaScript and such. So Streamlit syntax is also very easy to understand, and you can literally guess what syntax you need to use. For example, if you want to write text to your screen, you would use st.write. To add a button to your app, you would use st.button. And so it's very guessable, as you can see. And you can already see that with this, you can be able to build apps really much faster, and you can guess what the next function is for whatever you're trying to add to your application. Streamlit also makes it easy to incorporate interactivity into your app with very few lines of code. Streamlit elements encompass functionalities such as text inputs, file uploads, multi-selects, and data visualization. These elements are also the building blocks of Streamlit apps. And Streamlit is constantly developing new features that extend the capabilities of Streamlit even further. Streamlit is immediately operational in your existing data-centric workflows. Because Streamlit is a Python framework, it's compatible with your favorite Python libraries such as Altair, PyTorch, Vegalite, and much more, like you can see on the screen. So pretty much anything you can do in Python can also be done in a Streamlit app. Streamlit also works seamlessly with your favorite AI tools like Llama Index, Pinecone, OpenAI, LangChain. I mean, the list it ends at this point. And so the Streamlit API docs are a great place to start your journey of building Streamlit apps, and you can access them at docs.streamlit.io. We also have a gallery for you to explore thousands of public apps that you can draw inspiration from to build your applications. And you can check them out at streamlit.io/gallery. Streamlit is used operationally by top data teams from companies like Google X, Airbnb, Uber, and many more. Even LanceDB today are here, and they use Streamlit quite a lot. And so Python developers across the globe also love building and sharing their Streamlit apps. And so you can see here a wall of love here, where you can see with a lot of folks sharing their Streamlit apps. And we also have a very strong community that is ready to support you in your journey of learning and building with Streamlit. You can visit our forum at discuss.streamlit.io and our community programs page at streamlit.io/community to get started. So when it comes to deployment, you can deploy unlimited public apps, Streamlit apps, and one private app on the Streamlit Community Cloud. And if you're a Snowflake user or customer, you can build Streamlit apps on top of your data with Streamlit in Snowflake. Streamlit apps can be deployed with most hosting providers, and you can visit our community deployments wiki page for deployment tutorials. Streamlit also supports multi-page apps, meaning that developers are not limited to creating apps with a single-page architecture. These concepts form the foundation of Streamlit. But once you've got a handle on the basics, there's a ton of ways to take your apps to the next level. There's components, themes, layouts, and so many other. So get started today, have fun, and we can't wait to see what you build. All right. So that concludes the intro to Streamlit. Now, I want to welcome Ayush, who's a senior machine learning engineer at LanceDB. And so, hi, Ayush.
Hey Tony, thanks for having me.
Yeah, absolutely. Super excited to have you on today, and you'll be walking us through how to improve our RAG application. So I'll turn it over to you to take us off.
Thanks. Yeah, I'll start by sharing my screen. Okay, just let me know if you see my screen.
All right, you're good.
Awesome, awesome. Okay, so the title of this talk or this collab is optimizing RAG retrieval performance using LanceDB, habit search, and reranking. So I'm going to start off with the basic question of what is RAG and why do we need RAG. So I'm pretty sure most of you have already seen a lot of content or beginner-friendly content about what is RAG. So I'm not going to take a lot of time here. I'll just quickly breeze through it. So essentially, um, with the advent of LLMs, we realized that these are the most powerful models that we've ever seen, and these can be used as chatbots or general chatbots because they can be trained on general text available on the internet. But there are a few limitations to general LLMs. First is that you cannot retrain LLMs very quickly because these are gigantic models. So with that comes a limitation that there is a training cutoff date, right? So you cannot always keep the information up to date. And now what this does is it makes them prone to hallucinations, which means that when you ask something that these models don't really know about, or the training data does not really contain that kind of information, they start to generate random messages, which might be misleading. Now, to solve that problem, an architecture which is called retrieval augmented generation or RAG was introduced. What this essentially does is it plays to the strength of LLMs, which is these LLMs can take pieces of information and create like seemingly human sentences, right? Like human level natural language generation. But you know what they are not good at is giving factual responses all the time. So what RAG does is it augments LLM with an existing knowledge base, which essentially means that you want to introduce a layer of a knowledge base between query and LLM response. So instead of asking questions directly to the LLM, you give them a query, you give the LLM a query with certain context, and you basically ground LLM. And you basically saying that I want you to answer based only on this with this context and nothing more. So this way you basically control hallucination, and this architecture is known as a RAG. Now, getting RAG out there is pretty simple, but there's a bunch of frameworks out there that you can invoke to create and deploy an LLM application within like less than 10 lines of code. The thing is, how do you go about improving a RAG? Um, Unlike any complex system, RAG essentially consists of these parts, right? So these contain individual parts that can be tuned or improved. So, I mean, just for the sake of argument, there's the first part is the data itself. The second part is the retriever, and we'll discuss a lot about retriever because this is the main sort of topic for the discussion. So retriever is the second most important part, and then the generator itself, the LLM, is again a third component of. And broadly speaking, there's also the embedding model, but that I've just included that in the retriever section. So we can just improve RAG as a whole by improving any of these or all of these components. So I've mentioned like some of the common techniques are using different query types, which will cover hybrid search, re-ranking, and then chunking techniques, right? So when you take these documents and you embed them in your knowledge base, and this knowledge base can be anything. It can be a vector DB, vector store, or any sort of database, which can even be graph database. So how you chunk these documents and store them, that is also another way of if you sort of run an ablation study based on the chunking techniques, you will see different results. But then there's also fine-tuning embedding models, because your retriever is as good as your vector embeddings. Maybe use a larger model for embedding. Maybe use a better model for generation of text, because as large the model is, more information or larger training data it can be trained on, and things like that. So there's a bunch of things, and it's really easy to get lost. Now, when you embark on this journey, I think the first thing that you should focus on is picking off the lowest hanging fruits. Most of these techniques, when you talk about fine tuning an LLM, or working with chunking strategies, you have to essentially go back to your system and redo most of the crucial components. So for example, when we're trying different chunking techniques, you have to rebuild your entire knowledge base with those chunks. When you're talking about fine tuning an embedding model, you have to go back to training, and it can take even weeks to get a good result. uh, Same thing with fine tuning a general LLM. So in this section, so essentially the argument is that why not start with the lowest hanging fruits, the simplest thing that you can just tune your retriever without changing other components, without going back and deleting your existing knowledge base and rebuilding that. Why not first experiment with the components that does not need to change the entire architecture or entire knowledge base. So here we'll cover mostly about what a retriever is, because as good as the thing is, like, if a retriever is really good, the context that you get out of for the queries will be really good, and LLMs will have really easy time answering questions without hallucination. So that's the crux of your RAG system. So what is a retriever, right? So let's get into that. So retriever generally with LLMs or RAG systems these days are vector databases. So you take some data. In this case, it's mostly text, but in sometimes these days it can also be multimodal data. But essentially, a vector DB takes some piece of information and converts it into, oh sorry, not converts it, but it essentially stores that data and its vector representation. And with that vector representation, you can sort of find in the vector space, you can find similar examples to a given query, or similar knowledge points to a given query. And this is what you sort of augment your LLM with to reduce hallucination, or to get nice answers to your queries. So this is essentially what retriever is. And in this collab, or in this talk, we'll be using LanceDB as a retriever. So I'll just do a quick introduction to what LanceDB is and what are its strengths. So LanceDB is a multimodal database for AI. It is powered by innovative and open source in-house file format that we've built called Lance. There are a few things that LanceDB, the few unique features in LanceDB. First thing is that it is zero setup. So you don't really need to have a server running. You can just pip install and import it and start creating your tables and running vector search. It essentially scales up on disk, which means that it is not an in-memory database. It can basically scale up on disk, so you're not limited by the size of your memory. And because it is powered by our Lance file format, which essentially is an alternative to Parquet, and provides speeds up to 100 times that of Parquet. So essentially, it means that you are scaling up on disk, but you're getting speeds, read and write speeds comparable to memory, so in-memory databases. So that's in a nutshell what LanceDB is. So it's a general database for multimodal AI. Now it comes with the native support for vector search, full text search, hybrid search, and re-ranking. This is what we are going to see next. All right. So now that we've set the context, I will start getting into the practicals. So I've just executed this Colab. You can also uh, I guess we'll put a link in the description later on, and you can also execute this same Colab. So the data set that we're going to use is uh, it's Llama 2 review paper, and that has essentially we've created a synthetic data set out of it. Again, this is all open source. You can find code here in this repository that I'll link to. And so what we've done is we've taken that paper, divided that into chunks using Llama index chunks, chunking method, and we've prompted an LLM, OpenAI in this case, to generate for each given context. So each given chunk, we generated two queries. So you'll see that for each chunk we have two different queries, and then an answer as well. Now, in our case, answer is not important because we are just building the context database. We are not building or testing end-to-end RAG. So our query and context is the most important part. So remember, what a retriever does, it takes a query and returns a bunch of context. And then we combine those and send that to an LLM to get a final response. But the heart of the problem is getting the right context. And this is what the retriever does. Okay, so we have this data now. Now, ingestion. So LanceDB essentially supports all uh, popular Python data ecosystem data types or file formats. So you can, if you're working with Arrow, you can ingest Arrow directly. If you're working with pandas, if you're working with JavaScript objects, polars, Python dictionaries or lists, or even Pydantic, you can essentially ingest data from all of these sources. And so the idea is to make this as Pythonic as possible for machine learning centric crowd, right? So what we'll do here, in this case, I'm just going to use Pydantic because we have an embedding API, which I'll breeze through quickly because that is sort of not the topic for this discussion. But essentially, what it means is that our embedding API automatically vectorizes your data while you ingest it and when you query it. So it essentially makes the process of modeling and dealing with vectors and stuff manually, it just makes them disappear in the background. So what this means is that I have, like, I can choose an embedding model. So in this case we have an integration with Hugging Face. So from the registry I choose Hugging Face and then pass in the parameter. So in this case I'm just going to use BGE small for embedding my data set, and I just have to define a schema, which is what the table or the database will look like. So the first column is text, and I will mark that text as the source field, which means a source field is tied to a vector field. So for every given source field, we will have its vector representation automatically generated by LanceDB. And so the second field, as you can guess, is vector field, and we will mark it, we'll name it vector. And then once we have defined that, I mean, obviously we can have multiple other fields such as ID and other things, but just to keep it simple for this talk, I've just kept these two fields. And once the schema is defined, we can just go ahead and create a table. So here we'll import LanceDB. Again, no setup required. Create a connection to local file system, and then create a database. So I'll just name this table QA data and pass in the schema that we've created here. And that's pretty much it. Now I don't have to think of converting my text into vectors and stuff. What I'll do is I'll just create a Python dictionary of all my texts from the data frame that we saw, and I'll just add those context to the table, and I'll print the table contents. So you can see the table is automatically generated. We have two columns, text and vector. Text is something that we ingested, and vector columns are now automatically generated by LanceDB in the background. We did not have to do any work there. Cool. So now we have our basic vector DB setup. We have text and we have all of its vector representations. Now, how do we query with LanceDB? That's the next step, right? So what are different types of queries? So LanceDB allows you to switch query types by setting query type argument. So by default, a vector database does vector search or semantic search. So the syntax for that is table.search, and you pass in the query. Now, if you're using embedding API, as I'm using here, you don't even need to pass the vector. You can just pass a string. It will automatically, based on the schema of the embedding API, it will just convert that into background in the background. But yeah, even if you have vectors, that's also fine. So you just pass the query and the query type, and by default it will automatically deduce the query type. So I don't even have to pass vector if I'm using embedding API. Now this is a pretty simple sort of syntax. Now how do you perform re-ranking. I'll come to re-ranking in a bit, but the syntax essentially is in this query builder object, you just call dot re-rank and pass in your desired re-ranker. And I'll speak more about re-ranker in the next step. Again, full text search, or BM25 as you might have heard of it, is a keyword matching algorithm. So it does not search stuff on semantic meaning, on the basis of semantic meaning, but it searches on keyword matching algorithm. So if you just pass in your query and set the query type to FTS, it will perform that type of search. So it's pretty simple. You just have to define the query type, and that's it. You don't have to do anything else. And the re-ranker pretty much the same. Same for hybrid search, but let's see what a hybrid search is before looking into the syntax. So hybrid search in general, not in the context of vector databases, hybrid search in general essentially means combination of multiple search techniques. Right? That is it. But in the context of vector databases, hybrid search essentially or generally these days means vector combining the results of vector search or semantic search with full text search or keyword sort of sparse search, right? So what happens is if you're performing if you're working with multiple searching algorithms, you'll get multiple results. As you can see here, you have a vector search result and you have full text search result, but you have to combine them somehow to get the final result. So a re-ranker does is it takes multiple sources of results and using either its own metric or existing metrics, it combines them together and re-ranks them again uh, based on certain criteria, and then gives you the combined results. That is the whole crux of vector search and hybrid search and re-ranking, right? So to perform hybrid search with LanceDB, again, the same syntax, pass in the query, set the query type, and if you, by default, it will use a very simple re-ranker, but you can, again, pass in a custom re-ranker in re-rank function. Okay, cool. So that is the basic syntax of how you do these things with LanceDB. Now, we have the data. We have ingested that data in a vector database powered by LanceDB. Now let's create a utility function to perform the same kinds of vector search or different type of lookups, so that we don't have to repeat ourselves over and over again. So what I'm going to do is I'm just going to define these are all the possible sort of query types. Right? We can perform vector search, we can perform full text search, we can perform hybrid search, we can perform vector search with re-ranking, we can perform full text search with re-ranking. No hybrid search with re-ranking because hybrid search obviously always needs a re-ranker. So there's no need to sort of, again, perform it. So here's just a sanity check, just so we don't really pass bad arguments. The crux of the code is essentially here. So if we get a vector or full text search, we just, perform table.search, and we limit to top k because we just want to evaluate something on top k results, right? You cannot get. So the thing is, with LLMs, you only want to pass a certain number of contexts. You don't need to pass. You won't really pass the entire context. It just defeats the whole purpose, right? So it will again get more and more confused. So we just limit to a particular top k. In this case, this is 5, and then we convert that to pandas. Now I'm converting it to pandas because it's much more easier to sort of read. But again, LanceDB has integrations with all of the popular data types or data providers in the entire Python ecosystem, right? So you can convert it into pandas, pyaro, lists, pydantic, anything that you want, anything that you work with in your larger code base or pipeline. With re-rank vector or FTS, again, the same thing. We will pass a given re-ranker. And then here's an interesting thing that I'll talk about, which is we sort of increase the top k value with a certain factor. Why do we do that? When it comes to vector only or full text only re-ranking, the thing is, for re-ranker to make any sense, right, you need multiple sources of search results, and then you re-rank that and get the top k out of it, right? So in hybrid search, you get two sources, you combine them together, and you have two times k results, right? Because those are two sources, and then you re-rank them and then get top k. So that it has some sort of effect on the end result. But let's just say you get only vector search, you only have 5 results, and then you re-rank them. Even if you just completely change the order, you get still the same top 5. It does not change. So to work with vector search re-ranking or full text search re-ranking, we just create an overfetch factor so that we fetch more results, re-rank them, and then go back to getting the top K. So I'll come to that later on, but this essentially is the idea. Because without that, re-ranking won't have any effect. And then finally, hybrid search, right? That's pretty much it. Now we have our sort of basic setup. Let's just look into the evaluation metric. Now, evaluation metric we are going to use here is hit rate, that is used to evaluate a vector database. So hit rate essentially means that for a given query, uh, how for a given context, sorry, for a given query, the extracted, how many of the extracted contexts sort of match the desired context. So which essentially means that uh, I will go through my entire query column of the database, and I will search for that in the database. Now, based on the top five results, if the top five results extracted from the database match the given context that I was expecting, the ground truth, it will count as a positive result. Otherwise, it will count as a negative result. And towards the end, we just sort of combine them and get the mean of like how many we actually got right, and that is called the hit rate. Now, most of the code essentially here is for exception handling. So it's like if something goes wrong, let's not stop, let's keep going, right? So that's pretty much it. So it takes the table, the data set, the query type, top K, and the re-ranker. Okay, now we have everything. Now let's start to run these tests. So with LanceDB, you don't really have to create a vector index for doing vector search, although you can. The thing is, because it is powered by Lance file format, lookup is generally really fast for smaller sized tables. So, up until few 100,000 rows, you don't really have to create uh, an index, a vector index. So in this case, I'm not going to create that because we just have 200 entries. But full text for full text search, you need to create a full text search index. So I'll create that here. Now let's get hit rate for vector search and full text search first. So to get the hit rate, we pass in the data, we pass in the table that we created, and we pass the query type as vector. The same thing with FTS. And let's look at the results, right? So vector search gives us 64% hit rate, and full text search gives us 59.5% hit rate. Okay, so now going back to our discussion, if you are treating, let's just say, full text search as a good baseline, which generally you should do, which I'll come to, there is some data supporting that. Just by changing the query type to vector, I have increased my hit rate by 5% or 4 or 5%. Right? But there's more, right? Let's look at how much can we push it using just that. So remember, if this was a RAG system, I'm not messing around with my data. I am not messing around with my embedding model yet. I'm not messing around with my LLM itself, which are most time-consuming things. But these also show these are difficult to do, and they change your entire system. Now, now let's try hybrid search. So with LanceDB, you can just use any re-rankers that you want. I'll use linear combination re-ranker because it is the simplest and the fastest. And what this does is it takes vector search results, full text search results, and it combines them by giving 0.7 weightage to vector search results. So essentially, it means that when it will re-rank stuff, the score will be zero point 0.7 times vector search score plus zero point 0.3 times full text search score, and whatever the final score is, we'll just sort the results accordingly and get you the top five. So, oh yeah, I missed one important thing here. With the result set that we get from this, we'll again just get the top K just to handle the overfetched results. So I just didn't want to increase this line here. You can just do it here. But essentially, you see whatever we overfetch, we re-rank, and then we go back to top K. So it's getting the same number of results, right? So yeah, with linear combination re-ranking and hybrid search, the result goes up slightly, right? We were at 64. The best score was 64. Now it's 64.5, right? And you can change that weightage, like how much weightage you want to give to vector search versus full text search. But this is a general idea. Let's try some more re-rankers, right? LanceDB has like a bunch of built-in re-rankers, and you can also build your custom re-ranker, which will come to later on. Yeah, I guess we are doing good on time. Yeah, I'm just really conscious about that. Okay.
Yeah, you're good.
So, yeah, you say something,
No,
Tony?
I said you're good. You're good.
Okay, sounds good. So the next re-ranker that I want to show you is cross encoder re-ranker. So I mean, if you've worked with transformers, cross encoder is bi-encoder is like a pretty common technique. So you just have a transformer like model, then you pull it, and then you just create a cosine similarity. You can pass multiple sentences, uh, and you know you would get vector representations also if you remove cosine similarity, the head itself. What cross encoder does is it takes multiple sentences as input, like here in this case, sentence A, sentence B, and it has a transformer like model, but on top of it, it builds a classifier. So it essentially sort of gives you a score of how, like, what is the similarity between these two sentences, right? Um, so with how cross encoding re-rankers work is with every query uh, and its context. We form query context pairs for each sort of context that our vector database gives us, right? Whether it's full text search or vector search. So we create pair of query and context, and a list of it is passed to a cross encoder model, and then that model assigns scores, right? How similar this particular context is to query. We want really the highest similarity for the best results, and then based on that score, we just arrange the results, which is called re-ranking. So one sort of quick difference is that linear combination was not doing any modeling itself. It was just using existing scores, so it's faster. Yet, like it is much simpler. Here we're invoking models itself. Now to use that is pretty simple. You just import cross encoder re-ranker, and then you just pass this initialize that, and you can like pass in model name or whatever. But I'm just using the default here, and then just pass in the re-ranker. This gives us 67.72, which again is like, I guess, about 3% improvement over the best results of the previous best result, right? Now coming to Coher ranker, like these are the last ranker that we will try. Um, so the syntax is pretty much the same. Here's the syntactical sugar to just get the secret from Colab. So I've just saved my secret to Colab. Again, you can get Coher API keys. It has a generous free tier, so you can try that out. Yeah, I've saved my key in the in Google Colab. The same thing, I'm using Coher Ranker v3. By default, it uses version 2. Both models are pretty good, and the results that you get is 75.9%. And so I just want to go back to the initial argument as to so up until now we've improved the whole spectrum of results. If you go back to it, is from 59.5 to 75.9. I guess like we could say 76. So it is more than 25 or 26% hit rate improvement without even touching any of the embedding models or these things, right? So this is what is possible with hybrid search or re-ranking and using different query types. So I've compiled all the results here. Again, all of these, whenever you see re-rank, you can understand that this you can just yeah, it's just pretty much Coher ranker, right? So that those are the results here. So we start with vector search 64, FTS 59, re-ranked vector. I'm not showing re-ranked vector here because for in the interest of time, but yeah, re-ranked FTS also gives you pretty much the same result as re-ranked vector, and hybrid re-ranking with Coher just blows everyone else out of the water. So it works really well. And results on, if you look at results on other data sets, I have one sort of a squad data set is not filled up because I was running the benchmark but I couldn't finish it, but I have run multiple tests. So you see the same Uber 10K SEC filing data set, you have similar results. Vector search gives you 60%, FTS gives you 82%. Now you might see there's a bit of difference, a lot of difference between this result. This can happen, and that's why it's really important to analyze your data set and test different query types, because some data sets queries contain very like similar keywords to the context. So full text search will generally work better because you're just searching the keywords there. And so it's really important to tune that. But again, if you look at re-ranking, Coher re-ranker just improves the result still, because over 82% improvement is more difficult, but it just again gives you 3% improvement from 82 to 85. So what I have realized in my results, in my experiments, the Coher re-ranker sort of works really well. I mean, whatever they're doing, it's working really well. And another takeaway is that full text search is generally a good baseline. Right? This data set that I have generated, the one that we're seeing now, the way it's generated is it is semantically challenging, which means that it does not contain a lot of keywords. So full text search is generally penalized there. That's why you're seeing vector search perform really well. But in general, I've seen one takeaway is that, you know, uh, if you look at all these results, this is an example of data set that I was trying. Uh, vector search in again, this is the same sort of CSV that I dropped, so the same similar results. But a full text search generally works really well out of the box, so you should just try that out. Yeah, and this is a Streamlit app that I built for anyone to sort of just quickly evaluate your retrievers on multiple query types and multiple data sets. So the link to that is in the collab itself. It's called Ragged. And when you run this, you will see a screen something like this. You can select a data set. I have integrations with Llama Index datasets, Quad, or CSV, which is like you can just drop a CSV. And you can select a metric. Right now, it only supports hit rate, top K. Let me just zoom in a little bit. I'm not sure if this is zoomed in already. Okay, zoomed in. Cool. So in this application I'm running locally, you can just select the embedding provider, which in this case I've selected Hugging Face. You can select anything you want. You can just pass in your reranker. In this case, it's none. And you can select a query type. If you do all, you will get all of these results. I have selected vector. So it is just giving me the vector search result, right? So this is the same data set that I've used here. So you will see the results are pretty much the same. So what I'll do is while I'm talking through this, I will sort of run this for every query type. And let me see if this sort of executes before I finish talking. Cool. So use existing table essentially means that I won't be creating a new one because I just ran it. It will just reuse that. Okay, cool. Now, we've seen re-ranking, but you can implement your custom re-rankers with LanceDB as well. It's a very simple API. Just import from re-ranker and just subclass it. So you can implement these three functions called re-rank hybrid, re-rank vector, and re-rank FTS. Re-rank hybrid will give you vector search and full text search results. You can combine them together, do some custom business logic here, and then return the combined results. In here, you can add custom filters, to specifically filter out certain results, certain keywords, and things like that that you might need based on your sort of application. And then the same thing goes with re-rank vector. It will only get the vector results. You can just do something with it, return the re-ranked one, and things like that. So, and using that is again pretty simple, like this. Now, takeaways and trade-offs. The takeaway is that this is the easiest, or at least when you're using LanceDB, we make it really easy for you to use these different types of query types and re-rankers. So it is the easiest method to significantly improve accuracy. Right? You're not really touching most of the other parts of the pipeline in your RAG system, which might sort of disrupt the entire thing. You're just tuning the retriever itself. But it is an expensive operation. Right? Depending on what re-ranker you use, you are either invoking an API in case of Coher, or you are performing some sort of, or you might sort of invoke a really large model in case of cross-encoder re-ranker, or maybe some other complex operation like linear combination re-ranker. So you're doing some of those things. So it is expensive. Here's like, I did this benchmark, I guess a few months ago, but this is the numbers that I got. This is speed or the latency that each one of these causes. So, I mean, based on your internet speed, and I think Coher Ranker v3 works really faster than this. So, but again, you can see there's a significant latency. This is another takeaway. And obviously, to counter that, because you're saving a lot of time and effort, both like directly and indirectly by saving engineering resources, even not fine tuning. If re-ranking sort of removes the need for fine tuning for a certain case, you might invest those resources here. So if you have a warmed up GPU environment running cross, and these numbers are, by the way, like from Mac M1. So these are not CUDA numbers. So when you're running CUDA, it might go down to like the same level as linear combination. But yeah, still, it's a good enough penalty, right? You don't really, if an application is strictly real time, you would not use it. So I guess in applications, I would say it's not recommended for problems that are strictly real time. Right? For example, you start search suggestions, or you start typing, you want those results, right now. And it's been sort of, there's been a lot of studies, a lot of big companies that, you know, bad result or bad autocomplete experience or suggestion experience can cause customer churn. So you definitely, when it comes to those kinds of application, you want speed or anything else. But there are other category of applications where, you know, getting accurate information need not be real time. For example, personalized music or movie recommendation. I guess it's such a bad picture that I chose, but because it's not visible. But anyway, uh, so here, imagine you're getting push notifications, or getting your personalized playlist from Spotify, uh, and things like that. So these are, or maybe your photo gallery app sends you, like, rearranges your photos, in some sort of cron job or something like that. In these sort of situations, you don't really need to be real time. You can just run something. You can start off with a general recommendation and gradually improve it, and then, you know uh, basically, user does not need to get those suggestions right then and there. You can just improve stuff behind the scenes. Another application is social media personalized timeline. You can create some, you can rank some posts as they come, and maybe, there are situations where you are shown a post from a few days ago, because that becomes relevant to you, as and that. And then recommended blogs, videos, etc. YouTube has started pushing out this sort of slightly, and depending on who you ask, this might be slightly annoying, that this they've started to give you notifications for recommended non-subscribed channels as well. So again, this does not need to be real time because no one is expecting that. So I mean, these are the kinds of applications that habit search and re-ranking can definitely allow you to just skip all of those you know harder to implement techniques for improving your RAG application. So yeah, let's see how we're doing here. Okay, this did not run completely, I believe. Oh, I did not provide a re-ranker, and I was, so all of the things that require re-ranker are null. But yeah, we got vector search and full text search results for the same data set, which, if you look closely, matches the one that we got here. So yeah, this application is also linked in the collab itself. So I think that's pretty much it. I'm not sure if I covered it all in 30 minutes, but yeah, I tried to. Happy to take any questions that you might have. I'll stop sharing my screen.
Yeah. This was great. This was very insightful demo as well, and kind of like talking us through and showing us how it works. And I think the question that maybe, as the audience are asking questions, yeah, please feel free to add your questions. I'll go ahead and ask you one of the questions here. So maybe I'm working on my own project. I'm listening. I'm watching you, giving this presentation right now, and I'm thinking, okay, so you've shown me that I could improve my what I get from my RAG application by using rear anchors and the different techniques there. So how would you, in terms of just kind of I guess level of or order of tuning, you have like rear anchors, and then you can tune the embedding models itself, and then all the way to the LLM. How would you maybe categorize that from the top? Like, this is the first thing maybe you should do before you get all the way advanced down the road.
Awesome, awesome. Yeah. So yeah, I mean, I guess if the application allows, and this also, like, sort of crosses the lines a little bit to, like, product side of things. So the thing is that I'm seeing, like, most applications need not be strictly real time. But what I mean by that is, there are other, you can just hide some abstractions from the user. So, for example, there are certain inputs that user might need while onboarding stuff, or like doing something that the network round trip even just takes a couple of seconds maybe.
Yep.
So you can just hide the latency of vector search or full text search, things like that, behind those as well. But again, with that aside, if you are fine with your application not being very strictly real time, if you are fine with a couple of 100 millisecond penalty, I would start here definitely, because it's the easiest thing to do and it's the least disruptive, right? Like, if you have a system, you don't really want to again re-ingest the data that takes a lot of resources. If you are already ingesting like hundreds of millions or even tens of millions, that takes a lot of time, GPU resource, and things like that.
Yep.
And then you don't, and also don't really want to sort of fine tune something from the get go, because then fine tuning is not just invoking a script. It's more about, is my data set itself that on which I'm going to fine tune is clean? Is that clean enough? Do I have to I can evaluate that? So that's again a rabbit hole that uh, you want to get into that rabbit hole if you like strictly have to, right? If there's a way to avoid that, maybe let's avoid that. So I would first look at my baseline, which again I would choose full text search as the baseline, and then I would say, if this is my baseline, let's just say it's 77% of hit rate, and for my application I need 80%, like more than 80%. I guess it's pretty close, right? It's doable. So let's just try these re-ranking techniques, and if it like sort of gets there, we're fine. But if it's something like you need 80% and your performance is like 40-45%, then I would say that even if pushing, the re-rankers and hybrid search won't cut it, right? You will have to optimize either the embedding model and the generation or the generator model. When choosing between both of those, I would say generator model fine tuning I would like to avoid it because these models are generally the largest, right? Embedding model, you can get a small embedding model and you can iterate much faster there. Just choose a small model, choose a specific data set, and then you iterate much faster. And uh, I would rarely even go towards fine tuning. Excuse me, fine tuning the generator model because these models have been trained on a very large corpus of data set. If you mess with that, you are either lacking that kind of data set that you want to train on, and things like that. So I would generally like keep that to the last resort. But yeah, that would be my answer. Yeah.
Yeah, very insightful, especially with the latency issues, because then it depends on your use case for your application, of course. But yeah, thank you for that insightful answer. And so I want to welcome the community, people that are watching. Please, if you have any questions for Ayush, please put it in the chat. This is the time that we'll fill some of those questions as well. And also, I want to open the floor here. If you're watching and you have a demo that you want to demo, like a Streamlit app or something, feel free to let us know in the chat. We'll send you a link, and then you'll be able to come on the stage and be able to demo your app. We still got a few more minutes here to go through. Uh, Otherwise, while we wait, Ayush as well, yeah, you've used Streamlit app here in your demo. How often do you use Streamlit apps within your projects at LanceDB?
I mean, whenever I try to, I mean, I use Streamlit whenever I can, essentially, because the thing is, I find myself writing the same blocks of code over and over again, and so the first step is to convert that into a simple API that I can just use for myself, and then to make anything presentable, I would then generally it's a gradual next step, right? You don't want to repeat yourself, then okay, you write an API. Then you want to be able to present your results, you write a basic GUI, and Streamlit makes it super simple. So I've been using Streamlit for a while. I've built a few projects here at LanceDB itself with Streamlit, even my personal projects. So yeah, I think it's a gradual next step once you want to present your work to the world. It's a Streamlit is definitely a no-brainer for me. Yeah.
Awesome. Yeah, I love that. I love that dry, technique. So yeah, I love
Yeah.
it. So I think we have a question here from Camille, and he says, "Are there any guidelines for which re-rankers are best for specific data sets, or is it just a matter of testing per application?"
I mean, a practical answer is that I've been seeing Coher Ranker perform really well across the board, right? Obviously, like I don't know what that model is because it's a closed source model. Um, but yeah, it comes down to your data set. I guess the bigger question here is what performs better on your data set. You have to figure that out first, whether it's full text search or vector search, because then you know that the kind of data set that you're talking about, is it more semantically challenging or is it easier just to perform a keyword lookup. So once you know that, then I would say some penalty can be reduced because you can just do away with FTS, re-ranked FTS itself. You don't really need to include habit search. So you just cut off one operation, which is like vector search plus full text search re-ranking. You just have one sort of pipeline there, one path of execution. So yeah, that is my advice. But yeah, specific to re-rankers, I think yeah, you need to test it out. Yeah.
Awesome. We have another question here from Bolahan from LinkedIn. He asked, "Does LanceDB work for pictures or images as well?"
Yep. So LanceDB is vector database is just one feature of LanceDB. LanceDB in general is a multimodal database for multimodal AI, right? So it essentially means that it is not a vector only database. In general, in vector databases, because they are persisted in memory, what you need to do is, and memory is definitely, compute is expensive, storage is cheap kind of argument there. So they generally store vectors only and some metadata around it. But with LanceDB, it is created in a way because it persists in your storage, not in memory completely, because of the Lance file format. What happens is you can store anything you want, essentially bytes, right? So whether it's images, videos, whatever, right? You store that, and and in fact we have an embedding API integration with Clip as well, so you can just build a multimodal retrieval application in like 5-10 lines of code. Yeah.
Awesome. He also asks, what of re-ranking for images based embeddings?
Yeah, so right now out of the box, we only support text embedding functions, but yeah, the thing is, there's no blocker in supporting other types of like multimodal re-rankers. You can implement it using the API that I shared. But I would also be interested in finding more about these models, because the models that I'm seeing that are coming out, like even for example Coher Ranker, I don't think it supports um, multimodal embeddings. It's mostly text re-ranker application. So I think it also has to do with demand. I think as more companies, for example, yesterday we saw launch of Gina re-ranker model. It's mostly about, I think it's about demand. As we see more re-ranking get more common, companies might start to build multimodal re-ranking model. This is what I was talking about, by the way. This happened, but yeah, sorry, go ahead.
Yeah, absolutely. Yeah, no worries. I think that was the last question I'm seeing in the chat. If anybody still has a question, and also still calling for demos, if you have a demo, please let us know. The stage is open. You can come on. We'll bring you on and be able to share your demo. It doesn't have to be anything sophisticated. It can just be a Streamlit app that you're really proud of that you want to share. So feel free to come on and let us know. Let us know in the chat. We'll send you a link. Also, if you have any questions, Streamlit related, or what Camille talked about, or not Camille, but Ayush talks about, please please let us know. And here's another question from
Mhm.
a LinkedIn user. So it sounds like you can use LanceDB to replace Pinecone and MySQL or Postgres.
Yeah, I mean, you can definitely do that. It again, you have to evaluate these tools. Obviously, representing LanceDB, I would say yes, do that. But it's up to you. I would personally say I know a lot of people that have been using, because LanceDB again supports all of the Python data ecosystems. It also supports DB, so you can just run SQL queries with LanceDB as well. So it's totally possible. And the convenience that you get is you have all your vectors and all your data also in one place. Right? So makes it simple, and also in columnar format, right? So yeah.
Yeah, great. Yeah, great response from Caroline. They say the content is so hot that it killed the electricity. I love it. That's fun. All
Yeah.
right. We got a question from Maz from LinkedIn, and he asks, has LanceDB scaled to serious scale reliability?
Oh yes, LanceDB excels right now mostly at scale. Right, you will get most out of LanceDB at scale if you look at some of our case studies. Um, on our website that we've already launched, you see some of the largest, or leading bleeding edge AI companies, Gen AI companies are have either been using LanceDB or have switched to LanceDB because uh, because they need to work at scale. For example, you might think of Midjourney or other companies like that we serve. And the thing is, they found out that at scale, LanceDB excels even more, because I mean, there's a lot of reasons. But the thing is, when you're working with in-memory databases, and the both costs and complexity grows exponentially. It's never linear, right? Because you have to control multiple pods, and architectures get more and more complex. Now, what happens with LanceDB is, because it is a much simpler architecture, because we are innovating in the storage layer itself. Right? We are sort of building a file format on how you store data in hard drive, which is much, or SSD, which is much simpler. Uh, and so it becomes much more noticeable at scale. So I would argue that, if you are performing something at scale, you should definitely use LanceDB. So it's definitely ready for scale, even if you right, like they're definitely ready for scale, even if it's not ready for smaller scale. Yeah.
Awesome. I think that's a good way to put it.
Yeah.
And we have another question here from, I think it's getting buried under here, from Sebastian from LinkedIn as well. What about Cobra version 2? Have you got any experience with this model?
We sorry. So let's just back. So we have integrations with I think Colbert V2 as well. So I will share my screen for 5-10 seconds to show you where to look. If you go to LanceDB docs, here you can see in the guides, you will see re-ranking. And here we have like all the supported re-rankers. So Coher, linear combination, cross encoder, and Colbert. And in this, you just have to pass in the right model, which is like version 2 or whatever. So yeah, this is the usage as well. And here you can find building custom re-rankers. This is what you want to use when you want to build your own custom re-rankers for, I guess, multimodal setting. Yeah. I think I lost your voice, Tony.
Oh, yeah. Sorry about that. I'm back now. Yeah, we have Patricia from watching from YouTube. If I have a file in PDF format, should I upload the text and images separately to have them vectorized, or can I somehow submit the entire PDF? I'm new to the topic of RAG.
Yes. So to build a rag, you need to chunk your text somehow, because need to divide your entire knowledge base into chunks of context. That is what you want to fetch. So you can use any chunking techniques. You can even build your own logic, but excuse me, it is recommended to use some of the Llama Index or LangChain or any other sort of provider, because they've worked extensively in creating these chunking techniques, right? So yeah, just use them, chunk your data set or PDFs. It should not take, like, the APIs are very high level, so it should not take more than 1 or 2 lines of code. And once you're there, it's really easy to ingest anything in LanceDB.
All right. So I think we might be getting down to the last question here before we close out. Uh,
Okay.
Camille also asks, you may have mentioned it, but how are you chunking your inputs? Any strategies on that end for better results?
Yes. So I'm pretty much using Llama Index for. Oh yeah, that answers the question. Okay, but yeah, you should, depending on the type of data that you have. This was a paper, so I just used text chunking, like the default sentence chunker. But if you're chunking code, there is a different tool for chunking code, and all of those are essentially modes um, in this library. So I would say just make use of that, because these are being maintained by engineers every single day. So these are going to be generally better than what you would come up with on yourself, right? Yeah.
Great. I think that was our last question, and just want to say, I mean, overall, great. A lot of really good questions today, fielded, and really awesome demo. And I think everybody here walks away with having knowledge to be able to improve their RAG applications going forward. So, just want to thank you, Ayush, for coming on and being able to share a lot of information here. So, thank you again. We'll be following your work, and maybe in the next couple few months, few years, we'll be able to come back again and do another demo of something that you guys will have introduced down the road as well. Just want to say thank you. Thank you for coming on the show.
Thanks for having me. Yeah, it was really great. Yeah.
Awesome. And so for everyone that's watching, thank you so much for tuning in. I hope you got some really awesome information today. And I want to encourage you to be able to follow us on LinkedIn, YouTube, Twitter, all our social media platforms. We do a lot of this live streams every twice, at least twice a month. And then we also have office hours at least once a month. So please follow us for more of this content so you don't miss any of it. You'll get notifications that way. And with that, I just want to say thank you and see you on the next show. And